Apologies, my apologies.
Okay, what we have here is some molten sulfur. And the molten sulfur takes on a sort of a ruby red or brownish color. Sulfur naturally occurring is in an S8. It's a spherical molecule, cyclic molecule composed of S8, although there are smaller and bigger versions of the ring within any naturally occurring sulfur. And one of the interesting things about sulfur is that when you heat it up past its melting point and then cool it rapidly, it forms an amorphous solid so that it remains plastic. We're going to cool it rapidly by immersing it in water.
Ooh. It's like blue.
Now it's burning because it touched the hot spot on the beaker. It burns with a very blue flame.
That's cool.
Yeah. I'm just going to put that out.
I heard this is.
Is it like solid now?
It's burning now. We're going to leave it over there. I melted the tongs a little bit. Forms an amorphous mass that is not solid. It can actually be there's amorphous sulfur.
Oh my god.
Its plastic properties. Kind of messy. And then within several hours it'll return to its harder state. Sometimes minutes. But the reaction can be catalyzed. I don't know what you would have to add to make it harden faster, but by noticing that by playing around with it, it also returns to its normal state. So it's cool to the touch, but it still has plastic properties. Now we have a little bit of a problem here because the rest of the sulfur, as you can see, is on fire. It burns with a fairly interesting colored flame. See the color of that flame?
Mm-hmm. It's blue. Ooh. Oh my god. That's good.
Well, there goes that beaker. The effects of thermal shock.
Broke.
I cooled it too rapidly so it cracked.
Oh man.
At least the fire's out.
Yay.